titled Vector and Matrices, right? Vector and the matrices. So it says the transformation, no, my bad. The transformation matrix, yes. A is equal to 0, -1, 1, 0. It represents a 90 rotation anticlockwise about 0, the center origin. The transformation B is 0, -1, -1, 0, which represents a reflection in the line with the equation y equal -x. All right, no problem, no problem. All right, now it says write the coordinate of P prime, the image of P, all right, after it undergoes a rotation 90 degrees anticlockwise. 90 degrees anticlockwise, the matrix for that is 0. So this is the A matrix, 0, -1, 1, 0. And this is now being used to multiply by 7, 11. So in carrying out our multiplication, it's 0 times 7 plus -1 times 11, then 1 times 7 plus 0 times 11. It's the same row by column concept. So what we have is -11, I think I'll leave it, this is 7, -11, 7, all right? But the coordinate of the P prime is actually, let's write it properly. The coordinate of P prime has to be written like this, -11 with a 7. So we have to be careful how we actually represent what they ask, right? So -11, 7, that's for that. Now let's go further. T is a combined transformation of A followed by B. Determine the elements of the matrix representing T. Now, what we want to understand, when we have transformation followed like a combined transformation, it's like we're doing functions here. So we have to be careful how we attack this. It's going to be the B outside and the A inside. This is how we're going to have to. So that transformation is BA. All right. So the one on the inside is the one that is used first, just like when we're doing a composite function, which means then we have to set up the two matrix in such a way that we'll have the B matrix there and the A matrix there. Remember though, that matrix multiplication is not commutative. So if you put the A1 to the left and the B to the right, it's not going to be good for you. All right. Not going to be good for you. So let us write them 0, -1, 1, 0. So I'm writing my A matrix 0, -1, 1, 0. And then I'm writing my B matrix, which is 0, -1, -1, 0. So it is 0, -1, -1, 0. So what I'm saying is this is what we need to multiply row by column. So we're talking about 0 times 0 plus -1 times 1. Then we're talking about 0 times -1 plus -1 times 0. Underneath now, -1 times 0 plus 0 times 1. All right. And then we're having -1 times -1 and plus 0 times 0. So what's my final thing? We have a -1. I get 0 there, get a 0 here again, and I get a +1 here this time. So I'm looking at that. So the combined transformation is -1, 0, 0, 1. You just multiply ordinary matrix and go. And this is the response for that. So that is the transfer, that is the transformation T, correct? Now, describe geometrically the transformation represented by T. I'll say this to you. What you can do is take a point and then look what happened to it. For example, I'm going to be using, so I'll soon describe it, but let me use it to see what happens. Let's check out a point. Check this out. Let us say I'm using any point. Let's say I'm using a point 7, 11. If I use 7, 11, no, negative 1 times 7, negative 1, let me fix this, hold on. Negative 1 times 7 plus 0 times 11. And then I'll have 0 times 7 plus 1 times 11. Now let's check this out. I'll end up with negative 7 and 11, which means that my coordinate would have changed from, check this out, it would have changed from a 7, 11 to a negative 7, 11. What transformation would have done this to a point? It kept the x value the same, it kept the y value the same, and changed the sign of the x value. Definitely, this is a reflection in the y-axis. Because when you reflect things in the y-axis, the y value remains and the x value changes its sign. So this is definitely a reflection in the y-axis. And the y-axis is the same thing as x equals 0. Anyhow you want to feel about that. So definitely, that is how you would have approached that. Let's go for more questions. Now, other question says the 2 by 2 matrix C is defined in terms of a scalar constant k. As you could see, C is equal to 3k64. Determine the value of k given that the matrix C is singular. What's the concept of a singular matrix? The concept of a singular matrix is simply that the determinant of that matrix must be equal to 0, which means that we're going to take the product of the leading diagonal, which is, so let us work out this, the product of the leading diagonal, which is 3 times 4, and I'm going to subtract the product of the non-leading diagonal, yes, which is 6 times k, and this should equal to 0. Let's continue working. 3/4, 12 minus 6k is equal to 0. 12 is equal to 6k. By getting the 6k on that side, we add 6k to both sides. Let me divide by 6, divide by 6. 2 is equal to k. So if k is equal to 2, then we will get a determinant of 0, which means we have a singular matrix right there. There you go. Let's jump into the vector questions. There's nothing sweeter than some vectors, right? It says in the diagram below, O is the origin, OX is U, and OY is V. We're looking at O to Y, O to X. We have those. They gave us those. OX and OY are extended so that X and Y are midpoints of OA and OB. All right. So I'm now told that X is the midpoint of that. So I'm going to put U here, and Y is the midpoint of OB. That means I could put V there. Midpoint is the middle, so I could put the other half on the other side of them. All right, so we have those. I normally label as I go so that the future questions will be a little bit more easier to look at. Now the question says express bx in terms of u and v. Bx. Now let me just drop my bx here so that we could see what we have. We want to express bx right here. Right, so we're dealing with bx right there. So I want to deal with bx going in that direction. Guys, if I want to go from b to x, and I'm on my position vector system here, I am going to be moving from b to o, and then I move from o to x. B to o, I'm going the opposite direction of the arrow that I got, which means it's going to be negative 2v, and then o to x is simply plus u. So that is my response there. That's my quick response to you right there. Let me fix my v, properly. Hold on. All right, minus 2v plus u, and that is my bx. Let's go for more. Questions are here. It says, given that ya and bx intersect, right? Given that ya, I want to from this. Let me check if I missed a question. Okay, I did miss. I'm looking if I missed. I think I missed a piece of a bearings question now that I'm thinking. Yeah. All right. We're gonna have to go back to that. I missed a piece of my bearings question. It says, given that YA and BX intersect at M. All right. So there's an intersection going here. So we're talking about BX and YA. Where's YA? Where's BX? Let's look at YA and BX. So they're saying to us here that YA right that they're saying that YA intersects BX at M. And when it happened, right? When it happened, we're told that BM is equal to 2MX. BM is 2 times that. So BM is going to be 2/3 of the ideal, 2/3 of BX, and MX is just simply 1/3. All right. So now let's see what they want, really. What they want. Let's go back for the question. We want to express BM in terms of U and B. So I want BM, but in order for me to find BM, I need to find BX and then take 2/3 of it. All right. So let's find BX. Now, BX, I could work out BX right here, guys. BX is needed to find BM. So BX is to move from B to O plus from O to X. Did I work out BX already? Why do I feel like I worked out BX already? I have BX. All right, good. So if I have BX already, then 2/3 of BX, all right? 2/3 of BX is BM. So I have it already. 2/3 of BX is BM. All right, let's go. You know what is BM? BM is equal to 2/3 of BX, and BX is -2B plus U. It's 2/3 of it. Let me just re-explain. Because based on the context, when they said M intersect here, it is saying from B to M is 2 times BM. In other words, B to M is twice as big as MX. So we could share it up in a ratio of 1 to 3, 1 to 2, should say, where this is 2 times that idea. So that's what we're talking about. So then I could say that the entire line is in 3 parts and B to M is 2 parts out of the 3. That is why I use 2/3. And then what I'm going to do here with my 2/3, I'm going to distribute it inside. All right, so if I distribute my 2/3 inside, I'll have 2/3 times -2V plus 2/3 times U. We could see this is going to give me -4/3 V plus 2/3 U. This is my BM, just like that. So that's my BM. That is actually -1 1/3, all right? -1 1/3. So I have that. Now that is my BM. Let's go for the next question. Because the next question, where is it? Hold on, guys. Okay. All right. The next question, I'm not seeing it here. So it probably fell off. But what the next question actually is, the next question says that given that YA, yes, and BX intersect at M. No. I will do that already. I'm going to have to edit this video. The next part, which is the B part, says using a vector method. Using a vector method. We want to show that the ratio, we want to show this, show that YM to YA is 1 to 3. Show all working bases. We need to show that. Now, all we need to do is to find YA, find YM, right? So we need to find YA, find YM. Now, YM, looking back at what we have there, let's go for YA. If I'm going to find YA, I'm going to move from Y to O, then I'm going to move from O to A. Remember though, YA is minus B plus OA is 2U. So there it is, I have my YA. Now I'm going for YM. YM is to move from Y to B, plus I want to move from B to M. Now, Y to B is V. And then I know what BM is. We just did BM right there. So BM is minus 4/3 V plus 2/3 U. Now, when you put this together, and these are the like terms right there. These are the only like terms. That's the only like term right there. So then, what we want to do is to work this out. Let us work this out. Now, let's think about what does negative 4/3 means. It means negative 1 1/3. That's what it means. So if I have negative 1 1/3 V and a positive 1 V, which is what we just call V, then you could see that we will be left with negative 1/3 of whatever. So this would have given us negative 1/3 V leave, because it's like positive 1 and negative 1 1/3. When the positive 1 and the negative 1 cancel out themselves, we are left with negative 1/3, and that's what we have there, plus 2/3 U. Now, I want to prove this. Now I have my vectors, they want me to prove, that this is in the ratio of that. You know what that means? You know what that means? That means that YA is 3 times bigger than YM, right? YA is 3 times bigger than YM. That means if I multiply YM, watch this, if I multiply YM by 3, I should get YA. That's what they're saying. So let us try to prove that now, and then we're done. Because this is my YM. So YM is, look at this, YM is negative 1/3 V plus 2/3 U. Now I'm going to do 3 of it. So it means then I'm going to put the 3 out there and then distribute it. No, 3 times negative 1/3 V plus 3 times 2/3 U. Check this out. This 3 into itself 1 time, into itself 1 time, 3 into itself 1 time, 3 into itself 1 time. So those cancel. What am I left with? I'm left with here a negative V and a positive 2U. This is my proof, because check this out. This is exactly that. Hence, we have proven that. All right? We have proven it. Well, that's the end of the paper. Guys, please like, subscribe to Daily Maths Concepts, because we're doing some serious mathematics here. All right? So share this. All right? And drop some comments.